Today we're going to be looking at Unit 10, Section 3. We're going to be looking at regular polygons, the interior and exterior angles, as well as the sum of those angles. A regular polygon is a polygon that is equilateral and equiangular. Remember, equilateral means all the sides are the same. Equiangular means all the angles are the same. So, that's the idea of a regular polygon. So let's talk about the sum of the interior angles. Now, we all know the sum of the interior angles on a triangle is 180. We know that. And we also should know on a quadrilateral it's 360. Well, let me show you an idea of where the 360 comes from. I'm going to draw a line. Now, with that line, I have two triangles, here and here. Well, this one we know adds up to 180. This one we know adds up to 180. 180 plus 180, 360. Now, I'm not going to split it up any further. I'm just splitting it up to one solid triangle. Once I have one triangle, I'm not going to split that any further. In other words, I'm not going to split this triangle into two triangles. Once I've got one triangle, I'm done. So let's apply that idea to a pentagon. I'm going to just choose the top one here. See, that's a triangle. I'm not going to touch it any further. Another triangle, and another triangle. 180, 180, 180. Add all those up. The sum of the interior angles in a pentagon is 540. Let's try this with a hexagon. I'm going to split here. Split here. Triangle, triangle. Triangle, 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 triangle. So again, 180, 180, 180, 180. Add all of those up, 720. And I can do that for any regular polygon. The sum of the interior angles is always going to be that. There's a formula to make our life easy, so you don't have to count out triangles. And it's the number of sides. Our formula is 180 n minus 2. So if I have 15 sides, well, how many is that? It's 180 times 15 minus 2. So that's 180 times 13. Over here, do the same idea. It's 180, 32 sides, minus 2. So that's 180 times 30. That's how we find the sum of the interior angles. Now the sum of the exterior angles. So I'm looking for this angle, and this angle. What do they add up to? Well, given the shape I have here, a triangle, I'm just going to say there's a 90, 45, 45. Linear pair, so that's going to be 90. Linear pair, 135. Linear pair, 135. I add that up, that's 270, 360. Let's look at a square. 90, 90, 90, 90. 90 plus 90 plus 90 plus 90. All of it added up, 360. And I could keep demonstrating this idea, but as a simple concept, the sum of the exterior angles is always 360. Well, if it's got 15 sides, it's 360. Well, if it's got 24 sides, it's 360. 37 sides, 360. 100 sides, 360. No matter how many sides the polygon has, the sum of the exterior angles is always 360. Now let's look at each interior/exterior angle of a regular polygon. The idea is fairly simple. To find the interior angle, this is on a regular polygon. Remember, on a regular polygon, all of the angles are congruent. I take the sum, I divide by the number of sides. To find the exterior angle, I take the exterior sum, divide by the number of sides. So, a 6-sided polygon has an interior sum of 720. I divide by 6. And that gives me my interior angle. The interior angle. 720 divided by 6, that is 120. A 10-sided polygon has an interior sum of 1440. Divide by 10. The interior angle is 144. Over here, to find the exterior angle, you do the exterior sum, divide by number of sides. 360 divided by 6, 60. 10 sides. 360 divided by 10, 36. Now, note, 120, 144. 60, 36. 120 plus 60 adds up to 180. 144 plus 36 adds up to 180. It's a simple way I can do all of these operations at once. So I have this little thing that I work with every time. I have the interior sum, interior angle, exterior angle, number of sides. Note I didn't put the exterior sum because the exterior sum is always 360. I don't need to calculate it. Given any one of these, I can calculate the others. There's a relationship between the exterior angle and number of sides. Regardless which one I have, I do 360 divided by it, it gives me the other. Interior and exterior have a relationship. Regardless which one I have, I do 180 minus that, and it gives me the other. To find the interior sum, I multiply the interior angle and the number of sides. So let's apply this. So, I have 8 sides. So let's find the exterior angle. I did 360 divided by what I had, which is 8. 360 divided by 8 is 45. To find the interior angle, given this, I'm going to do 180 minus it. 180 minus 45. Now find the interior sum. I multiply those two. So 8 times 135, 1080. So given 8 sides, here's your exterior angle, your interior angle, and your interior sum. Alright, let's look at another example. If I'm given just the exterior angle, let's say the exterior angle is 20 degrees, let's find the rest of this. So the number of sides, remember the relationship is 360 divided by whatever you have. So 360 divided by 20, 18. To find the interior angle, these two add up to 180, so 180 minus 20, 160. To find the interior sum, I multiply these two. So 18 times 160, 2,880. Let's look at 2 more examples. This time, I have the interior angle. Well, I'm going to start by finding the exterior angle. 180 minus 150 is 30. Now let's find the number of sides. 360 divided by 30. Again, notice I'm always doing the same thing regardless which one I have. 360 divided by 30 is 12. Now I multiply these two. 12 times 150, 1,800. Now here, I have the interior sum. I have to take a little bit of break from my equation here and think back to what we originally did. The interior sum is 180 times n minus 2. So I take 6480, divide by 180, and I get 36. I add 2, because I'm doing the opposite. N minus 2, so I got to add 2. So I get 38 sides. Now to find the exterior angle, I'd go back to my normal thought. 360 divided by 38. 360 divided by 38 doesn't come out nicely. I round 9.47. Find the interior angle. 180 minus 9.47. And I get 170.53. Again, it's rounded. Now, to double check that I did this right, if I take this and multiply by here, I get that answer. And that's it for today. I'll see you next class.